Welcome to Click Academic. This is a lesson number 5 on the series of logic and set theorem. We'll be discussing on connectives in this very lesson, but this lesson will emphasize more on BI Implcative as one of the connectives that we mentioned earlier in our lessons. The previous lesson that we did, we are all discussing about connectives. So today's topic is all about BI Implcative, which you remember in the last class we see that we have material implicative. So this BI Implcative is also known as BI material implicative. We see that a compound statement formed by a connective, if and only if, is called a BI implicative statement. Now I'm trying to make a diagram in order to justify the statement or the above definitions of BI implicative statement. We say when we have two statements, a compound statement means we have two statements. We have statement 1, then if and only if, then statement 2. This is a diagram that will show you the two columns. Then from this proposition, which is you can let the statement 1 to be Q, then P, statement 2 to be P. If and only Q, denoted by this P BI implicate Q, or P is equivalent to Q, is true if both the statements are the same. That is, if true, then is true. If false, then is true. Otherwise, the statement is false. Meaning, we cannot have true, false, or false, true. It must be true, or false. That's what the statement is trying to say. Also, P BI implicative Q is true if P implies Q is true and Q implies P is true. That's how this is. Now let's justify using truth table. We have now, this is Q, which is true, false, true, false. Then we have true, false, false. Now when we said Q, P BI implicate Q, that is if and only if Q, then it's true, it's true, false. You see, they are not the same, so it's false. False, true, they are not the same, it's false. Then we have false, which is true. That's what the if and only if condition statement is. Then now we learn how to use this implicative in our previous class, which is we say P implies Q if and only if Q is true or both the statements are false. So now we say, okay, since Q implies P, now we are going to consider P column first. Then we have true here will be true. Okay, here will be true, here will be true, because true, false here with true. Then false, true is false, false is what is true. That's according to the implicative statement. Then we have P implies Q. Now we are going to consider Q since it implies Q. The column of Q, we have truth, false, true, which is what? False. We have truth, which is true, false, which is what? True. Now this is the statement. So then we have P implies Q and Q implies P. Now this statement and this statement, and say that is what is conjunction. When statements are true, both is said to be what? And. Then it's said to be truth. If the statements are different, then it's false otherwise. Then true is what? Is true. Then we have false true, which is false. False true, which is false. Then true is what? Is true. Now this is the statement. So I want to show you some things. Now if you look at this, P if and only if Q, true, false, and then P implies Q and Q implies P is true, false. Now if you look at this, true, false, true, right? So this shows that P if and only if Q is the same thing as what? P implies Q and Q implies P. Now this is the statement. Now this is what we are going to type whenever you see, because that's true if this and this is true. That if this is true, then this one is true. That's what the statement is saying. Now we are done with the connectives. So now we are going to talk about what you call well-formed formula. Well-formed formula, it likes to tell us how the formula is being stated using any well-defined connectives using it. So in the well-formed formula, we say all preposition statements are well-formed formula. You see like this now, Q, P here is a well-formed formula, Q here is a P if and only Q is a well-formed formula. P implies is a well-formed formula. This one also is, this one also this. They are all well-formed formula. But the only thing that we are considering is what? Like, let's take some example and see whether it's going to, show. We say that anything different from this above is not a well-formed formula. So now let's see how it goes. Like this example, we have negation of P. Now, if you take negation of negation, is just P, right? But now, P implies Q. It's not a well-formed formula because, like, P negation of P, this negation is not a connective, rather a unitary connectives. So it cannot be in bracket. Since we put brackets, so therefore this is a wrong. It's a wrong what? Well-formed. It's not well-formed formula because of this bracket. But negation of P is a well-formed formula. But once you put the bracket, then it will be wrong. Then this negation of this one is a well-formed formula. That is what we mean by well-formed formula. Thank you very much. This is the end of our class. Thank you very much.